In the previous video, we looked at how to apply the sine law. An interesting case arises called the ambiguous case, where the exact nature of the triangle may or may not be determinable. Now, we are going to first look at like how physically these can arise, and then with specific examples, we're going to look at how when you solve it, you would be able to identify each of these cases. So this is when the ambiguous case arises. Suppose you're given one angle and two sides, and let's say that the given angle is angle A and the given sides are A and B is somewhere here in all of our cases. Now, by the convention rule, this side is B, so the opposite facing vertex is B, and this is A, then A is somewhere here. Now, it might happen that the length A is not enough for it to meet this line. So in this case, we say no triangle possible. It would mean that with the given information, no triangle can be drawn. The second scenario is that this A is just about enough to make it into a right triangle here. So there's one triangle possible. The third case is that this A is such that you can have a triangle here and you can have a triangle here. So let's say B, and let's call it B1, B2. And these are both equal to A. Two triangles possible. And the last case is, again, one triangle possible. But again, this has a specific property that A equals B. And it would be an isosceles triangle. So think about it in terms of, let's say you are actually constructing it using a ruler and a compass. What you would do is you would draw this to be the base. You would select an angle and you would draw this length. And then from here, you mark the compass for the length A and you try to find where it intersects AB. So if it's too short, it's never going to intersect. If it's exactly tangent, it's going to intersect at 90 degrees. If it's just long enough for it to cut at two places, it's going to have two possible triangles. And if it's exactly the length of B, where B equals A, then it's going to be one triangle again. So that's physically, sort of analytically looking at what possible scenarios can occur and what do they mean in terms of the triangles. Let's actually look at some examples and see how they appear mathematically when you try to solve them. So the first one, solve triangle. You're given angle A, side A and B. So setting it up, I can set it up as A over sine A equals B over sine B. 7 root 2 over sine 45 is 7 over sine B. Right, so cross multiply, I get 7 root 2 sine B equals 7 sine 45. Unknown is B, so let's eliminate whatever that is not B. Sine B is sine 45 divided by root 2. What does that give me? Okay, I'm making sure, yep, still in degrees. Sine 45 divided by square root of 0.5, which is in the domain. Now, if you know sine B, how do you find B? We use the inverse function, right? So this is going to be sine inverse of 0.1. Sine inverse of, 0.5 is 30 degrees. Now the question is, remember when we take this inverse functions, what are possible values? Because of ASTC, a positive value is possible in quadrant 1 and quadrant 2. So let's check. This is the quadrant 1 value. The quadrant 2 value would be, this is 30, 30, this would be 150. This is not possible. Why? Because if angle B is 150, angle A is 45, 150 plus 45 is already more than 180. So there's only one solution possible. Let's look at the next one. Similar setup. A over sine A equals B over sine B. Actually, let me rearrange this. Already cross multiplying, A sine B is B sine A, or sine B is B times sine A over A. Then I just plug in 248.6 times sine of 43.1 over 186.2. So what does that come out to? 48.6 times sine 43.2 divide 186.2. That comes out to 0.91 roughly. Again, it's within the range or within the domain, so B can be sine inverse of 0.91. Sine inverse of 0.91 is 65.50 degrees. Now once more, dealing with sine means quadrant 1 and quadrant 2. So if this angle is quadrant 1 is 65, that's 65. So the quadrant 2 solution is going to be 180 minus 65.50. 114.5. Now this is possible. Why? Because this plus 43.1 is not more than 180 degrees. So there are two possible solutions. Yeah, so two solutions. Angle B can be 65.50, in which case angle C would be 180 minus 43.1 minus 65.5, 71.4 degrees, or angle B would be 114.5, in which case angle C would be 180 minus 114.5 minus 43.1, 22.4 degrees. And then, so you can complete this. Correspondingly, the side length C would have two different values. So two triangles possible in this case. Now say this is what you're given. Once again, same setup. A over sine A is B over sine B. Cross multiply. A times sine B is B times sine A. Sine B is B times sine A over A. Plug in 122 times sine of 42 degrees over 70. 122 times sine 42 divided by 70, 1.17. Sine B, this would be no solution because it's more than 1. So this is saying that the given information, if you try to solve this triangle, you get sine b to be more than 1, which is not possible. So this means there is no solution, which essentially means that no such triangle possible. Okay, so those are how mathematically, when you're solving, when you're applying the rule, you can draw the conclusion of whether or not a solution exists or how many solutions exist. We will look at a word problem in the next example, and then move on to the next idea of, it turns out that the sine law is not sufficient to solve all triangles. So we are going to look at another law. That's it for